So, what is a computer? I mean, really, we use them all day, every day, right? But have you ever stopped to think about what's actually happening inside that box? Well, that's exactly what we're going to do. Let's dive in and break it all down. Okay, so first things first, let's just take a second to realize how everywhere computers are. It's kind of crazy when you think about it. I mean, before the 80s, computers were these massive, super expensive things that almost nobody had. Now, they're literally everywhere, in our homes, our schools, even in our pockets. And it starts right at home, doesn't it? They've become our go-to tool for, well, just about everything. Need a recipe? Look it up. Gotta pay a bill? Done. Shopping, email, you name it. It's totally changed how we run our day-to-day lives. And hey, it's not all just work and chores, right? Think about your living room. The computer has basically become the command center for all our entertainment. This is a perfect example of what tech folks call convergence. It's this idea that everything, your games, movies, music, photos, it all comes together in one single hub. But it doesn't stop when you walk out the door. The second you're outside, you are still surrounded by computers. Paying for coffee with your phone? That's a computer. Scanning your ticket to get into a concert or a theme park? Yep, that's a computer too. They're like these invisible engines that are just running everything in the background. All right, so we've got it. They are everywhere. But what are they all actually doing? What's the secret sauce? Well, here's the cool part. It turns out that every single computer, I don't care if it's a giant supercomputer or that little smartwatch on your wrist, they all follow the exact same 4 basic steps. So what is that core function? It's not magic, even though it can feel like it sometimes. It's actually a super logical 4-part cycle. Okay, so here's the official kind of textbook definition. The 2 words to really focus on here are programmable and data. All a computer really is an electronic device that can be programmed, given instructions, to do stuff with data, which is just raw facts. And this cycle right here illustrates it perfectly. Let's break it down. Number 1, input. That's you telling the computer what to do. Let's say you type in 2 plus 5. Step 2, processing. The computer's brain, the CPU, does the math. It actually calculates the answer. 3, output. The computer shows you the result on the screen. 7. And finally, number 4, storage. The computer can save that result so you can use it later. Input, processing, output, storage. That's the whole game, right there. And this brings up a really important distinction: data versus information. See, the numbers 2 and 5 on their own, that's just data. They're just raw facts without any context. But when the computer processes them and gives you the answer, 7, that's information. It's data that's been organized and processed into something meaningful. It's the so what. Okay, so we know what a computer does, but how does it do it? How does it actually perform that whole cycle? Well, it all comes down to 2 key parts that have to work together perfectly: the physical machine itself and the invisible instructions that tell that machine what to do. And I absolutely love this analogy because it just clicks. Think of it like this. Hardware is the body. It's all the physical parts you can actually see and touch. But the software, that's the soul. It's the set of instructions, the consciousness that brings the body to life. You absolutely cannot have one without the other. A body with no soul is just a box of parts. Now check this out. What's so cool about this diagram is how all these physical hardware parts map directly back to that 4-step cycle we just talked about. See the keyboard and mouse? Those are your input devices. The big system unit there, that's where the brain is, the CPU. That's for processing. The monitor and the printer, that's how you get stuff out. They're output devices. And the hard drive, a USB stick, that's your storage. See? It all fits together perfectly. Now, for the soul part, the software, it basically comes in 2 main flavors. First, you've got system software. Think of this like the foundation and the operating system of a house. It's things like Windows or Mac OS. It's the stuff that just runs the computer itself. Then, on top of that foundation, you have application software. These are the tools you actually use to get stuff done. Your web browser, your favorite game, a word processor. They're the furniture and appliances inside the house. Okay, so now we have a pretty good handle on what a modern computer is all about. But to really appreciate the magic of what you have on your desk or in your pocket, you gotta see how far we've come. And believe me, it happened fast. So let's jump in the time machine for a second. The history of computers is usually broken down into these generations, and each new generation was sparked by one huge technological breakthrough that made them smaller, faster, and way more powerful. We went from these giant, hot, fragile glass things called vacuum tubes to tiny little transistors. Then we figured out how to cram millions of those transistors onto something called an integrated circuit, and that led to the final leap, the microprocessor. Basically, a whole computer on a single chip. It's what powers pretty much everything today. Just look at this thing. This is a first-generation computer. ENIAC. It took up an entire massive room. It used thousands of those vacuum tubes, which got so hot they could probably cook an egg. And the craziest part? To get it to run a new program, you had to physically go in and rewire it with cables. No typing, just unplugging and plugging stuff in. Then, in the late 50s, the transistor came along. And this was an absolute game changer. Suddenly, computers got way smaller, they were much more reliable, and they didn't need their own power plant to run. You could actually fit one in a regular office instead of needing a dedicated building for it. And all of that brings us to the fourth generation, kicking off around 1971 with the invention of the microprocessor. This was the moment where all the important processing bits could be squeezed onto a single tiny chip. And that, my friends, led directly to the very first personal computers, like this old-school IBM PC. This right here is the great-great-grandfather of the device you are probably using to watch this right now. But the story doesn't end there. The revolution wasn't just about getting a computer on every desk. The next giant leap was figuring out how to connect all of those computers to each other. And when we did that, we created something that was way, way bigger than just the sum of its parts. And that brings us to this key idea, the computer network. It sounds fancy, but it's really simple. It's just a bunch of computers and other devices that are all connected together. And why do we do that? For one simple reason: to share stuff. Whether it's sharing a printer, sharing files, or just letting people communicate with each other. This diagram here is a perfect, simple example of that. You've got a couple of PCs, right? And they're all hooked up to a central server. This setup lets them all share the same files, send emails back and forth, and they can all print to that one single printer. It's all about making things more efficient and helping people work together. Now imagine you take that simple office network and you scale it up, way, way up to a global level. What you get is the internet. The internet is the actual physical thing. It's this gigantic worldwide infrastructure of connected computers, servers, and undersea cables. It's the plumbing. And then running on top of that plumbing are the services we use every day, like email, or the most famous one, the World Wide Web. So when you really stop and think about it, the journey is just mind-blowing. In the span of a single lifetime, we went from computers that filled an entire room to a global network that connects billions of us. It's absolutely staggering, and it really makes you wonder, doesn't it? What's next? What's the next great leap gonna be?